5.3, network devices. So now we're going to learn about switches, routers, or a little bit about them, but we've kind of already talked about it. What connects multiple or allows devices to connect to a LAN, to a network?
Switches.
Switches. A switch is what layer device? Layer 2. It makes forwarding decisions based off of what address?
Your Mac.
Your Mac, aka physical. Now, what's our network boundary device? What allows us to forward data from one network to another? Router, which is what layer?
3.
3 makes routing decisions based off of what address?
IP logical.
IP, aka logical. All right, let's watch a video.
Ethernet switches connect devices such as computers, printers, and routers, which are on the same Ethernet local area network. Devices on an Ethernet LAN communicate with each other using Ethernet MAC addresses. The MAC addresses in this video have been shortened for brevity. These MAC addresses are embedded on the device's Ethernet NIC, network interface card. For example, when PC A sends data to server B, it does so by sending that message to the server's Ethernet MAC address, CCCC. When a switch receives a message, it examines the destination MAC address in the message to determine which port to forward the data. It is important to note that devices also use IP addresses to communicate. IP addresses are used by devices to communicate with each other on the same network, but are also used so they can communicate with one another when they are on different networks. So switches forward data within the same network, while routers forward data between different networks. In this example, PC A is sending a message to server B, which is on a different network. This message, known as an IP packet, is sent to the local router, PC A's default gateway. When the router receives this message, it will examine the packet's destination IP address to determine where to forward the data. Routers have routing tables, which tell them where to forward packets. If the IP address of the destination device, server B in this example, is not on a network directly connected to this router, it will forward the packet to another router. If the IP address of the destination device is on a directly connected network, it can then forward the message directly to that device.
Oh, yeah. All right. Fun video?
Yeah. Super fun.
Super fun. All right. Hey, NIC. What does a NIC stand for?
Network interface card.
Network interface card. Our BIA, or our burned in address, is on that NIC, i.e. our MAC address, our physical address. Now this NIC, it can be wired over Ethernet, which would be what or which IEEE standard? 802.
No, that's
Wired. Ethernet. 802. 3. If it was wireless, it would be 802.11. Very good, right? So we can see here, we've got a wired NIC. That's a wired NIC with an RJ45 socket. The next one we see is a wireless NIC, 802.11. And if your computer, for whatever reason, doesn't have network capability, here is a USB wireless NIC to allow it to have connection to a wireless network. Easy day? All right. We talked about repeaters before. A repeater operates at which layer of the OSI model? Layer 1, that's right. It's a dumb device. We can say that. It won't be offended because it's dumb. It can't hear us. Haha. So what a repeater does is when a signal comes out at 100% of a cable, the further distance it goes, it gets quieter. A repeater or an extender, once it hits there, it'll come back out at 100%, and then the more distance it goes, it gets quieter, right? The signal gets weaker. Easy day? Repeater, extender. Good to go?
Yes.
All it does is play telephone. All right, a hub. A hub is also a layer 1 device. That just repeats the signal everywhere that it sent it to. So let's say PCA sends a message to any of these other devices. It comes in to the hub just sends it out every other port. It doesn't know, it doesn't care, it just sends it to everybody. You get the frame, you get the frame, you get the frame, everybody gets it. I don't know who it's supposed to go to, so I'm just going to give it to everybody. Easy day?
Yes.
So this allows multiple devices to be connected, but this is legacy. Hooyah? Awesome. Now the next step up from that is what's called a bridge. A bridge allows us to place our devices into two segments. One over here, one over here. It keeps track of all the devices on each segment and knows, are you part of group A or are you part of group B? If it's destined for group B, then everybody in group B gets it. And so it'd be like if Burnett over here, he needed a special request chit. Well, okay, that's in group B over here. I'd give a special request chit to everybody, but not over here. Let's say that Garner needed a special request chit in group A. Well, then I get everybody in group A a special request chit. Still not very efficient, but a little bit more efficient because it's cutting the bandwidth hypothetically in half. Good? Or the use of the bandwidth. Next, so these aren't very efficient. What we use today, it microsegments and only sends it to the specific device. And it does that based off of the MAC address or physical address that it's going to. What device are we talking about here?
Switch.
A switch. A switch is what layer device? 2. Layer 2. Forwards information based off of MAC, aka physical. Later on in CCNA, we're going to learn about the MAC address table or the CAM content addressable memory table and how it learns, it builds based off of the source MAC and it filters based off of the destination MAC. But what it does is it microsegments. It knows, oh, this is PCC. This is B, based off of his MAC address, and it'll only send it to those devices. And we'll learn about certain situations when it does and does not do that later on in CCNA. Questions on a switch? This should be kind of easy now because we've gone a lot more in depth, right?
Yep.
Okay, and there's the picture of basically what's on the board, right? Switch, layer 2, MAC, physical, sends it to that device. An access point, also layer 2. This allows us to connect what?
Connects
Wireless devices
to a wireless router.
to the network, right? To our local network. What IEEE standard? Wireless.
Wi-Fi.
802.11. Very good. All right, moving on. Our layer 3 device is a
Router.
router. Routers make forwarding decisions based off of the
IP address.
IP address, aka
Logical.
That's the boundary for our network, right? So if that door over there is the router, is our router. It's got an IP address on the handle towards us in this room.
Right.
And it's got a handle on the outside, an IP address there. Our default gateway is how we get out of our network on the router. Is that going to be the handle or the IP address on this side of the room or on the outside?
This side.
This side, right? Our default gateway, how do we get out of this room? That handle right there closest to us. That's our default gateway. Our router, right? There's many different networks out there. The routers forward data from one network to another, so it can get to its eventual destination. Hooyah?
Yeah.
Questions? Okay, moving on. Let's see what we know. What is a legacy device that extended the number of devices that could be connected to a LAN? A hub. Layer 1. What is a device that connects networks to and forwards data based on the IP address?
Router.
Router. What layer device is that?
3.
3. A legacy device that was used to divide a LAN into segments. Bridge. A device that uses radio waves to extend the distance of a network.
Heater.
Radio waves. Let's come back.
Let's say extend.
A device that microsegments a LAN and forwards data based on the MAC address. Switch. A switch is our layer 2. What regenerates weak network signals? Feeder or extender. What connects end devices to a network?
Wireless.
All right, let's break this down.
Wireless.
Let's break why this is. Let's go back to the first one that we skipped. A device that uses radio waves to extend the distance of a network. Radio waves, what type of technology are we talking about? Wireless, right? So that's going to be wireless AP, wireless access point. And what connects end devices to the network? Well, what specific piece of hardware is that? That's your NIC, your network interface card. It can be wired, wireless, or wireless. Who ya?
Oh shit.
Let's show correct answer. Which one did we get wrong? Wireless AP and NIC?
Somebody gonna be running.
I think this is wrong.
No, we got it right. NIC connects end devices.
No, we got at least
Wireless AP.
It's wrong. Because MAC addresses is not wireless access.
Oh, I see. Okay.
It's wrong.
Yeah.
You were right.
Okay. Never mind. Moving on. Let's watch a video on security devices.
So Neticat is wrong?
Yes.
Aye.
On that one.
A firewall is a network security device or software within a device that monitors and controls incoming and outgoing network traffic based on a predetermined set of security rules. An integrated router typically contains a switch, a router, and a firewall. A firewall acts as a barrier between a trusted internal network and an untrusted external network, such as the internet. Firewalls use various devices to enforce a predetermined set of security rules. This may include one or more access control lists, ACLs, used to determine what type of traffic will be permitted or denied. Two other types of security devices are intrusion detection systems, IDSs, and intrusion prevention systems, IPSs. An IDS passively monitors traffic on the network, comparing the captured traffic stream with known malicious signatures. An IPS actively monitors traffic before reaching the destination. If the data is acceptable, the traffic is permitted. If the data is unacceptable, then the traffic will be denied.
All right. Sir, that question?
Oh, no.
Yep. All right. Firewalls. Does anyone know where this term originates from? Cars again. All right. There was a firewall between the engine, right, and the cab, the compartment where the humans are, to prevent you from catching on fire. Same kind of thing for our network. We've got our home network, but then we have the rest of the world, the internet out there, and it's a scary place, right? So we want to be able to protect our network. What a firewall will do is selectively permit or deny inbound or outbound traffic. So allow traffic into our network or deny it, or on its way out, allow it to leave or not allow it to leave. It can do it based off of a variety of things, including IP address, MAC address, keywords, ports, protocols, rules, etc. And it makes these rules based off of ACLs, or access control lists. Right? Oh, do you have access? Can you get on the list? Are you on the list? Can you get in to the club? Oh, are you on the list? Oh, God, yeah, I am. I can get in the network. If not, oh, the bouncer says, oh, sorry, you can't get in this network. And same for on the way out. Does that concept generally make sense?
We got a wristband.
All right. Wristband, yeah.
Firewall is basically just a bouncer for clip.
You got respect.
Yeah, so here we can see, right, here is our, if we scroll down here, we've got our internal network here. We've got our switch and we've got our firewall here. That'll prevent that outside traffic from getting in if it's not allowed. And I think we discussed the different types of firewalls next. Nope. Next is what's called an IDS and an IPS. IDS stands for Intrusion Detection System. IPS stands for Intrusion Prevention System. What sounds better or safer? Being able to detect or prevent?
Yes.
To prevent, right? Let's say I go on a date with someone.
Oh yeah.
They've got 3 kids from 5 different guys.
Oh.
That don't even add up.
It's okay. They're not working, and they're just living off of their retirement or something. I don't know, right? They're homeless. They're missing an arm. That, well, we'd call those red flags, right?
Yes.
So an IDS, right? What's an IDS going to do? Red flag, red flag, red flag. What's Mr. Novak going to do? Second date, here we come, right? But an IPS still, right, records red flag, red flag, red flag, and stops it right there, right? What it does, instead of allowing it to go into the network, that traffic, is it places it into a bit bucket so it can record it. So, in the terms of security, would you consider an IDS, intrusion detection system, a security device? Did it prevent me from ruining my life, going on another date?
No.
No, right?
It just.
So all it does is log. It records, right? So it's not even considered a basic security device. An IPS is considered a basic security device. Does that difference make sense to everyone?
Yes. Yeah.
So the IDS just allows everything through and it just logs it. But here we have the IPS. Here's our intrusion prevention sensor. If it notices an anomaly or an error, instead of allowing it into the network, it places it into a bit bucket, right? Instead of allowing it into the network, nope, you're going to go over here, and we're going to record that. So we can refer back to it later if we need to. Questions?
So the IPS and IDS is signature based, not necessarily like Crosa is.
It depends on which one you have, and we'll get into the different methods later on. UTM. This is a generic name. UTM stands for Unified Threat Management. Unified Threat Management. This is an all-in-one security device. Includes all the functionality of an IDS and an IPS that we just talked about, as well as a stateful firewall, or SPI. So stateful packet inspection. What that type of firewall does is it blocks unsolicited requests. What's an unsolicited request? Well, that's a packet coming into your network. Hey, I'm from AskJeeves.com. Here's this webpage you asked for. AskJeeves.com, what the heck? I never asked for that. A stateful packet inspection is going to block it. Does that make sense to everyone?
Yeah.
But let's say you were like, oh, you know what? I wonder if Ask Jeeves is still around, and you go to AskJeeves.com. Well, you're sending a request out to that website, right? If you send a request out, you should be expecting a response. So it keeps track of those requests. If you go out of your network trying to go to that, well, then it'll allow that in. But if not, if it's unsolicited, just randomly, hey, here I am. You didn't ask, but here I am. Would you like to buy a whatever? Door-to-door salesman sells a vacuum or whatever. It would block it, right? I didn't request you to come to my house. Nope. Not allowed in. So that UTM includes that SPI, or Stateful Packet Inspection, as well. Other things that it includes is zero-day protection. Ooh, that kind of sounds like zombies, right?
Yeah.
Well, think about, day zero. What's day zero in zombie movies?
That's the day of the first infection.
The day of the first thing, right? And what do you call the first person that got infected? Patient zero, right? So if we take that same thinking back to viruses or malware, 0 days are when someone discovers a vulnerability, a weakness in an operating system. And it takes a while for the vendor to identify that and update the security patch. So UTMs are able to help mitigate those risks against 0 days by updating the software, looking out for various heuristic efforts and signatures, etc. Booyah? All right, a DOS, denial of service attack. Y'all have siblings?
Yes.
Bernie, 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 Bernie. Someone else try to talk to Bernie. Bernie, 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 Bernie. It's difficult, right? So what's happening is I'm trying to overwhelm Bernie so that way he can claim PTSD and get disability when he gets out. No, the goal is to overwhelm a server, right, with lots of requests. And if a server is overwhelmed, what's going to happen? Well, if they make another request, they might not see it. So it's going to slow down that server. And legitimate users that are trying to talk to Bernie or talk to a server aren't going to be able to do that. Does that denial of service attack make sense? Yeah. The goal is to overwhelm the site, the service, to prevent legitimate users from accessing it. Now, for a large server, right? Bernie, right? He didn't get too bothered by that, right? Bernie's resilient. He's a warrior, right? So, but we could do a DDoS attack, a distributed denial of service attack. What the attacker will do here is they will infect thousands of machines all over the world. Right, Chat-san? You with us? Now, those infected machines, they don't know they're infected, and they're going to lay dormant, like zombies, right? So they'll be dormant until the attacker sends the code. And then in unison, all these computers all over the world, in unison, are going to start attacking Bernie. That makes it difficult to track down where it's coming from, and it's a larger coordinated attack. The users of those computers don't know what's happening, and it's a larger scale attack. Does DDoS make sense? Distributed denial of service. All right, let's scroll back up. What else does a UTM prevent against? We've got our proxy filtering. We learned about proxies earlier. You have an email filter for spam. We talked about DKIM. You have anti-spyware to prevent key logging or for recording your keystrokes or recording your information on your computer. And VPN services. That's all a part of a UTM, a Unified Threat Management, that generic term. Another term for UTM is a next generation firewall. What's a next generation firewall?
UTM.
It's a UTM, right? What does it do? IDS, IPS, stateful packet inspection, firewall, 0 days, anti-malware, all that stuff we just talked about. More time to write?
Yes, please.
Yeah? Okay. Now, this is a generic term, so of course, what's included will depend on which one you buy, the vendor, the manufacturer of that UTM, of that next generation firewall. Cheng.
So you could say like the UTM is like firewall on steroids.
Yeah, next generation firewall. So firewall plus more, right? Like not just a firewall with ACLs, but a stateful packet inspection or stateful firewall that'll track conversations out and block unsolicited requests, help protect against 0 days, et cetera, et cetera.
Sus Marioso.
More time? Garner? Cerner? Good. Anyone else need more time? Back row? All right. Good. Next, let's see what we've got next, which is endpoint management server. Endpoints. We're talking about host devices, end devices here. Well, you may be in charge of, like, think about in here in this classroom, we've got 50 desks, 50 computers, right? And that's just in this room. What about in 1099? There's a lot. How do you manage all of these devices? Because as an IT, remember, we want to be lazy. We don't want to have to get up and go to each computer. We want to be able to manage all of these devices remotely. An endpoint management device will allow us to do that. We can remotely update, configure, take control, etc. This is useful in these large corporate or enterprise environments to ensure continuity and compliance, that all devices are updated. And if there's issues, you can be on top of it. Cerna.
Is that kind of like when you put your screen on ours, or no?
That is a software that lets me control it,
Mm-hmm.
so you can think of it like that.
All right,
Yeah.
cool. Let's remember that.
This is
Oh, yeah,
kind of
that
like,
makes sense.
just like UTM, like an all-in-one package. This is what like services.
Correct, yeah, to control everything. Now this is a Cisco course, so of course they want to plug their thing. So here we have Cisco's Digital Network Architecture, or DNA. This is an example of an endpoint manager. And now we can move on. Or we need more time. Nope, all right, moving on. Spam, we already talked about all of these in this chapter. This is the exact same thing repeated, so we're going to skip that. And let's see what we know. A device that is installed in line on the network to evaluate traffic before forwarding it to the destination is what?
Firewall.
I'm hearing firewall, I'm hearing IPS. Raise your hand for firewall. Raise your hand for IPS. IPS has it. A device placed between an internal and external network to filter traffic based on rules defined in an access control list, or ACL. Firewall. A device that copies traffic and forwards to a management station for evaluation. IDS?
IDS.
IDS, okay.
Hold on.
A device that offers stateful packet inspection, or SPI, along with other advanced features. UTM, Unified Threat Management. A device that centralizes the view of all devices in the network so that the administrators can manage them from one interface. Endpoint management server. Very good. Any questions? No. All right. Let's go to the next thing. Legacy devices. What do we got here? Some old dip switches. All right, or embedded systems. Let's go down. I think it was talking about air-gapped. So air-gapped, we'll just talk about that now. That's we're all connected to the internet here, right? Right. So technically, right, if someone's got a way, they could find a way through the internet in here. Air-gapped networks, like those in nuclear energy or other things, air-gapped means they're not connected to the outside world, right? So to connect to them, right, you've got to physically get on that network somehow. That's air-gapped. Booyah? Booyah. Now, patch panels for some reason are in the legacy, but the military, we use patch panels a lot. And here we can see them here. All they're doing is allowing data to pass through them. You've got an RJ45 on one end, on the other end is an RJ45, or maybe it's punched down, etc. So basically, we've got some computers. The next thing we hit is a switch. And the next thing is a router. However, in between these devices, I'm going to have a patch panel. Patch panel here. Patch panel here. So this computer, right, will be connected here. Connect to the patch panel, and the patch panel just passes it through. This computer, connected, patch panel, just passes it through. Computer, patch panel, passes it through. Computer, patch panel just passes it through. The switch connects to the router, but first it's going to hit the patch panel and passes it through. Seems unnecessary, I would imagine, right? But let's say we've got all these other ports on these computers. Well, we'll wire these up, even though we're not using them yet, to the switch. Let's say this port went bad on the switch. Instead of switching that out, I could just connect this PC to a different port here, and it's connected, it's ready to go. reducing our troubleshooting time, how long it takes to fix something, right? Because this is already connected to all the ports on the switch. Does that make sense to everyone? So reducing that downtime. Also, we want to test things to make sure there aren't any issues. So when you're testing in the fleet, troubleshooting, you're going to hear the term, are you good in-house a lot? You've got to check your devices within your network. You want to make sure that the connection is good, there aren't any issues. So if we want to test from this router to this PC that it's good, well, I could unplug from this router and then plug a loop back in to test all of this. But the easiest way to do this troubleshooting is to just unplug this, attach your testing equipment, and send it this way. And it goes through and it'll test everything here.
Okay.
If we want to test this way now, well, we can disconnect our test equipment, plug this back in here, and now we can plug in our test equipment here and test it this way. Every cable, every device has now been tested. So that patch panel, you're able to quickly and easily do your troubleshooting all in one location. Right? Because that's one device, you just plug it in the back, plug it in the front, do your test, good to go. Who ya?
Yeah.
Questions? Moving on. Power over Ethernet. So here, this is a switch, but there's something special about this switch. Usually Ethernet cables can just provide data, but there's 8 wires in there. They can also provide power. However, in order to do that, that power has to be injected into those wires using either a PoE, power over Ethernet switch, or PoE injector, which will inject that power. Well, why would you use something like this? Well, think about a security camera. You need to have a power cable, and you probably want a data cable so you can get the data if it's not wireless. Well, instead of having a power cable that you've got to run and an Ethernet cable, you can just run an Ethernet cable. It'll power the device and do data as well. All from the switch. You don't need to connect it to an outlet because it's getting power from this PoE switch. Does that make sense? All right, there are different types of PoE. These are all in the Ethernet standard. What's our IEEE standard for Ethernet? 802.3. Very good. So these fluctuate based off of how much power they can provide. So PoE is 802.3 AF. That can do up to 13 watts at 48 volts. If we scroll down, Robert's question.
I'm sorry. Would a power line Ethernet adapter fall into like the same category?
Yes and no. We're going to talk about that next. If I don't answer your question in the next section, let me know. 802.3 AT is PoE plus. 802.3 BT is PoE plus plus. So PoE plus can do 25 watts. Plus plus can do 51 watts for type 3 or 73 for type 4. So depending on what you need to power, you need to know what type of PoE do I need. PoE, PoE plus, PoE plus plus. And naturally, if you buy a switch, PoE is going to be cheaper than PoE plus and PoE plus plus. But a switch typically is going to have a varying type and quantity of these various things. Below this, we see what's called a PoE injector. Maybe you don't want to buy a switch, or you just need to inject power into one cable. Well, here we have an in for an Ethernet and an out for an Ethernet. On the other end of that is a place for us to connect AC power to allow power to be injected into that cable. Good to go? We need more time for notes?
Yes.
Yes? Okay.
It's kind of just like a battery.
Not battery store power. This is providing power.
Okay.
So you know how you've got a power cable to your computer and you've got an Ethernet data cable. Think about for a security camera, if you instead of having a power cable and an Ethernet cable, you've just got an Ethernet cable that provides power and does data as well.
So is this useful for like places that don't have a power outlet nearby? Or?
Well, this isn't going to be enough to power a computer.
Yeah.
It's going to be low power devices, security cameras, some webcams. You can use this for a wireless router, wireless access point that can provide power and data to that as well.
Okay.
Let's say you want to put an access point on the ceiling here. Well, how big of a power cord would we need to get it there, right? That's an expensive cable, probably. So instead, we can just run an Ethernet cable, get data there, and power as well.
And these are legacy?
No, these are not
My
legacy.
dad
No.
did- We did that in my house. So we ran it all the way to the attic, all the way to the part bedroom.
Yep.
We did it later.
More time? All right, moving on. Here we go, Roberts. If I don't answer your question here, you let me know, all right? So we know that Ethernet cables are copper, right?
Yes.
Data. We know what they can do. They can do power as well, right? Hey, stand up. Stand up. So what else in our house, our apartment, has copper? Power, right? Think about electrical outlets, right? Well, think about our outlets, right? That's copper cable, and that runs throughout our entire house, right? You plug in an outlet, and you go upstairs, there's another outlet there. So let's say you've got your router downstairs, but you want more coverage wirelessly upstairs. Well, you'd have to run an Ethernet cable all the way upstairs or through the walls to get there. However, you've already got the copper infrastructure. So what you can do is do power line networking. You take an adapter on the wall like we see here, an adapter upstairs, and then you connect the data, and then through these power lines in your house, the copper in the wall, right, it will be able to send the data. This doesn't interfere with the electricity in your house, right? It's not going to like, oh, now I can't use the lights. Doesn't affect that at all, but it just allows you to send data. The one thing you need for this is an adapter. You can't just plug it into a two-prong outlet and it'll work. You've got to have an adapter like this.
Then I wouldn't have an excuse to buy more tools.
Then you wouldn't have an excuse to buy more tools. That's right. Tucker?
So, you're telling me that all this time that I've been running Ethernet cord for like throughout the entire house to get to my PC, I can just call one of these.
You could have done this, yeah. Coffee.
What is the disadvantage of this?
Speed.
Speed? Okay.
It uses power.
Yeah, you're using a little bit of
Is
power.
it like a heat box?
Ethernet would be better. Roberts, good?
So, just real
Chief?
quick, one of the big uses of this is, for example, in like a big city, in a skyscraper, right? And from talking to people that have lived in those, right? The wireless. Imagine if every single one of those apartments, there's thousands of them in there, had a wireless router, right? And all of the different signals that would be going on, it kind of would confuse things. Things would have a hard time connecting. Frequencies would just get saturated, oversaturated, right? Whereas if you do this option, it's a wired connection, so there's not as much saturation. So that's one of the big times I've heard that this is used, just to kind of help you get a good grasp of it, right? So also things like an apartment complex where they run a fiber to the complex, to the main office, say, but then your building is thousands of feet away, right? And we were already talking about repeaters. Well, there's not necessarily repeaters in apartment complexes, and your signal, you're paying for a really fast internet, but you're only seeing such a small little dose of that, right? Because of the distance. Well, this will help with that as well. Okay.
Looks good.
Everybody good?
Yes.
All right, last thing before our next break, and the last thing in this segment of Chapter 5, cloud-based network controller. We're going to learn about the cloud more throughout, but we're just remotely accessing things for now. That's what we can think about it. So if we've got a lot of end devices, this cloud-based controller will allow us to remotely access those things when we're on a different network. Here, Cisco Meraki, this is intermediary devices that Cisco does, and there's a way to manage all those intermediary devices, switches, and routers remotely for troubleshooting. You don't have to physically be there. Who, yeah?
Yeah.
All right, do we have a quiz before we go into 5.3?
Yeah.
All right. Question, Newton.
So is that similar to how like on our iPhones it has like our different devices that we have.
Yeah, you can think about it like that, but it's not going to be for that kind of devices, but for like switches and routers.
Okay.
So you're managing hundreds or dozens or thousands of switches and routers in different locations all over. Good, Newton, or are we just saying yes? Okay. All right, quiz. Sending data down power lines to network devices is what, Roberts? Or everybody?
Ethernet over power.
Ethernet over power. Okay. A system that no longer can be upgraded or patched. Legacy. Collection point for cable runs from networking devices. Patch panel. Device that allows administrators to remotely manage many devices through a dashboard interface. Cloud-based network controller. Sending low voltage electricity down a network cable to power devices. Power over Ethernet. Special purpose microchips that are programmed to carry out specific functions. Embedded. Questions, comments, concerns? No. All right.